Today is the 21st of May 2024. This will be our fifth lesson on probability. Okay, the new set that I'm doing to help revise and to add a bit more stuff and to bring a bit of clarity and to those who don't understand. Okay, thank you everyone who have subscribed to this channel. If you haven't subscribed already, I will appreciate it if you do. Okay, subscribe. When you get the video, share, like, comments, nice comments. Follow us as long as it's not going to cost anything. Do your part to help us circulate. Okay. If the account is not yours, please ask permission from the account holder or open your own account. In the comment section, you always see, please follow my notes/script. Okay, it's very important because at times things happen. Yesterday I was recording and my phone started to ring, so I couldn't pick it, but I thought it wouldn't get into the recording, but it did. Okay, so I had to pause a bit and re-say that part, which can be frustrating at times. Okay, so and at times some of these callers, they just call you, do you need that, do you need that, and most of them are scammers anyway. Okay, and they just think, oh, you are just there doing nothing, so you can just be picking calls. So beware of scammers. Okay, I said that, beware of scammers, because at times you are picking a call, you are not familiar with the number, and then somebody is on the background somewhere tapping into your phone records. Okay, seeing if they can get a clue into your inbox or your password or something. So be careful. It's a lot of pain now with all this technology. People have also become pro in stealing. It's not just going to the shops and lifting at guns and stuff. You can be at home and somebody can use your phone to tap into you, okay, without your permission. So be careful. Recap. I watched last video for recap. We've done a lot on probability, and I hope by now, if you have issues with probability, you should be able to be separating them. So when you see the questions, then you'll be like, oh, I know how to solve this one. I can apply the or law, or I can apply the n law, or I can combine it, or we are going to start looking at the tree diagram again today. Okay, so watch last video for recap. Again, mental maths for our starters, okay, because it's exam season and there is no way to help you think faster than to use the times table and you applying your factors and to use sets. Okay, with this as a full topic, which I did videos on, but I'm just trying to use the simple ones to help you think a bit faster. So the first one, root of 250. So 25 times 10, which will be root of 25 times 10. Okay, if you multiply back, you get 250. Okay, so root of 25 is 5 and root 10, so 5 root 10. Root of 1000, which is root of 100 times root 10. Root of 100 is 10, so your answer becomes 10 root 10. You are simplifying again. Root of 45 times root 3 root 3. 2 root 45 times 3 root 3. So 2 times 3 is 6. Okay. 45, you can break it down to 9 times 5. So you can have roots 9 times root 5 times root 3. Okay. Now root 9 is 3. Okay. So 3 times 6 is 18. Root 5 times root 3 is 15. So you have 18 root of 15. 3 root 12 times 3 root 3. Okay, so 3 times 3 is 9. Okay, root 4, 12 can be written as root 4 times root 3. Okay, root 4 is 2. Root 3 is 3. Okay, so now 9 times 2 is 18. Times 3 will be 54. 5, root 4 root 24 times root 2 root 5. Okay, so 4 times 2 is 8. Root 24 can be written as 4 times 6 and then root 5. Okay. No, 4 times 2 is 8, sorry. So you have 8 times 2, which is 16. Okay. Then you have this 2 here is here. So already we have 8 times this 2 here, which is 16. And then we have root 6 times root 5, which is root 30. So 16 root 30. 2 root 18 times 3 root 5, 3 root 2. Okay. So 2 times 3 is 6. 18 is 9 times 2. And then root 2. Root 2 is 2. So this is 2 times 3, 6, times 2, 12. And then root 9 here is 3. So 12 times 3 is 36. So today we are going to look at more examples on probability. Okay. So we've looked at the ordered one, ordered pick, not replaced. So you realize that as you pick it, you note the color. You didn't, you place it, you put it on the side. So it kept on reducing. So your second pick is what you have in the box. Okay. So let's look at this. Charlie has 9 colored sweets. Okay, sweets again in a bag. Charlie removes 1 sweet at random from the bag and does not replace it. Okay. Charlie then chooses a second sweet. Okay. Now, the 9 colored sweets, he has 2 red sweets, 3 blue sweets, 4 black sweets. Okay. In total, he has 9 sweets. Okay. He does not replace it after it's been removed. Find the probability of Charlie selecting the sweets in any order. So here we've been set loose. So he can either pick a red and a blue, or a blue and a red. So this is where you combined the end and the or law. You know that when there's end, you multiply. When there's or, you add. Okay, by now you should understand that. So, assuming first he goes in and pick a red, there is 9 in the box. So there are 2 red, so it will be 2 out of 9. Then there'll be 8 left, okay, and then he has to pick blue, because they said, what is the probability of a red and a blue? So there are 3 blue sweets, 3 out of 8. 8. Add, if you went first to pick a blue, okay, then it will be 3 out of 9. Then there'll be 8 left. So there are 2 red sweets, so 2 out of 8. Now, we can multiply the numerators and the denominators, and then whatever we get, we add together, okay? Or we can simplify here and then add together, because the denominators will be the same. The denominators are the same. So if we simplify in this step, okay, how many 3s do you have in 3, 1? How many 3s do you have in 9, 3? How many 2s do you have in 2, 1? How many 2s do you have in 8, 4? So you have 1 out of 12 plus. How many 3s do you have in 9, 3? And how many 2s do you have in 8, 4? And how many 2s do you have in 2, 1? How many 3s do you have in 3, 1? Okay, so again, another 1 out of 12. Because the denominators are the same, we are adding, so we can add 2 over 12, which is 1 over 6. Okay, so if you want to pick a red and a blue and does not replace it in any order, this is your answer. He now has to pick a red and a black in no order, so it's the same thing. A blue, 3 out of 9, not replace. A black, 4 out of 8. Add a black, 4 out of 9, not replaced, times a blue, 3 out of 8. So it will be a blue and black, or, which is this one here, and times, or add black and blue, because they haven't given us any order. So here we can simplify again. How many 3s in a 3, 1? How many 3s in a 9, 3? How many 2s in a 4? In a 4, how many 4s in a 4, 1? How many 4s in a 8, 2? So this part here, we have 1 over 6. which I've written here. It's the same thing. How many 4s in an 8? 2. 4 in a 4, 1. How many 3 in a 3, 1? How many 3 in a 9, 3? So 1 out of 6. Okay. So 1 out of 6, add 1 out of 6 will be 2 over 6, which is 1/10. Now see, a black and a red, okay? Also not in any order, okay? So first we go for the black and a red, or a red and a black, okay? So because there is and or, we combine it because they've not given us any order, okay? If they've given us an order, then we can't add the second. Then we have to go for the order that we've been given. But because we haven't been given any order, then we have to strictly consider all the orders. Okay. So 4 blacks, 9 sweets. Now there'll be 8 sweets. So 2 red, 8 sweets. Add 2 red sweets over a total of 9. Okay, and then 4 over a total of 8. Okay, because you are not replacing, anytime you pick one and you don't replace it, the total in the box reduces by 1. How many 4s in a 8? 2. How many 4 in a 4? 1. How many these two here can then cancel the remaining 2. Okay, so you have 1 over 9. Now, how many 4 in an 8? 2. How many 4 in a 4? 1. These 2 here will cancel these 2. So again, 1 over 9. The numerators are the same. So we add, the denominators are the same. So we add the numerators, which is 2 out of 9. That is the lowest we can simplify. Okay. So quickly, I'm going to introduce the tree diagram. Okay, I'm going to do a quick introduction, and then we'll take it from this thing. From the next video I'll put out. I've done some tree diagram with you. Okay, from the beginning. If you don't understand, go back and watch, please. Okay, that is a lot easier than the one we are doing now, but it's the same principle. Okay, so if you don't understand, go back there and watch. Okay, tree diagrams are used to solve problems with both dependent and independent events. Okay, so if you're able to put your information in a tree diagram, then you should be able to solve it, because it makes it a bit more visual, especially if you're a visual learner. Okay, Anita has 10 colored cubes in a bag, 3 red and 7 blue cubes. Okay, a cube is removed at random from the bag, color noted, and replaced. Okay, so here is removed but is replaced. What we just did earlier is not replaced. Okay. Anita chooses a second at random. Represent the following in a tree diagram. So here we are going to be replacing. I'll talk a lot about this in the next video. What we just did, a bit of last lesson, and now we didn't replace. Okay, but I thought I'll put this throw in here so that you have an idea. And then we've done a little bit of this earlier so that you can remember, so that when I introduce it next time, you wouldn't we wouldn't have to struggle with it more. Okay, so let's look at what Anita has. Okay, so now Anita's first choice, red red colored cubes. Okay, 10 cubes colored red and blue. Okay, in total she has 10. So to have a probability of a 10 cube is 3 out of 10. Therefore, the blue will be 7 out of 10 because the total probability should add up to 1. Okay. In this order, she's not replacing. Okay. Now, red again, we are representing it in a tree diagram. So if there's red now, to red is 3 out of 10. Red to blue will be 7 out of 10. These are the second choices. Okay. So again, red 3 out of 10, blue 7 out of 10. There is no replacement here. So if Anita wants a red and a red, look at it. That is the probability of choosing a red, 3 out of 10. And another probability of choosing a red. So this is the diagram you go for. So it will be a red and a red because it's not being replaced. Okay. And they've not asked us to choose it in any order. So it will be 3 out of 10 times 3 out of 10. Okay, so we multiply the numerators and multiply the denominators. That's 9 over 100. You remember I told you that the probability of choosing two things at the same time reduces the chance, because for you to get 2 red sweets the first time and the second time among only 3 red sweets makes it a bit more difficult. Now, the probability of a red and a blue, a red is 3 out of 10 and a blue is 7 out of 10. So here again, you have red and a blue. In this order, it will be 21 out of 100. Okay. The probability of picking a blue and a red. So 7 out of 10 times 3 out of 10. So a blue and a red will be 21 out of 10, no order. The probability of picking a blue and a blue, so it will be 7 out of 10 and 7 out of 10, 49 over 100. Okay, you will multiply the numerator and multiply the denominator. Okay, now because there are a lot of blues, the probability is 49 out of 100. which is nearly half. Okay, because there's a chance you will get a blue sweet than a red, because there are only 3 red sweets. Okay, so here, as as you have represented on a tree diagram in this way, you can use it. So assuming you are supposed to pick uh, a red and a blue, or a blue and a red, and replace it, then you just add these 2 bits. Okay, we'll talk about that next lesson. Okay, I don't want to confuse you. Go back and think about the examples I've given you. Look at it, understand it, and then get ready for next lesson. Okay. So I'll end here. Please subscribe, like, share, follow. Follow my notes last script, please, in case I've missed something. And beware of scammers, please. Okay. Thank you so much for joining me in today's lesson, and I'll see you in the next.